So to find the shape of the double bond in formaldehyde, let's go ahead and do the Lewis formula here. We're going to replace the shared pairs of electrons with lines. So these shared pairs, where I've got just one shared pair, I'm going to replace with a single line. But where I've got a double shared pair for a double bond, I put 2 lines there to show a double bond, okay? And I keep those lone pairs sitting out there on that oxygen, all right? What we want to do, the question number 71, is asking you to show the shape of the double bond. So a double bond contains a sigma bond and a pi bond, okay? So the sigma bond is that wiener or cigar shape.
I thought a double bond was a sigma and 2 pi.
No, a double bond has a sigma and 1 pi. Triple bond has a sigma and 2 pi.
So what does a single bond have?
Just a sigma. Just sigma. If it was, this would be just a sigma. If it were, this would be a single bond if that's all we had. But the double bond has to have a sigma and a pi. The reason we have to have 2 different kinds of bonds is for the same reason that we can't get more than 2 electrons in the same orbital. All right? You can only put 2 in the same orbital if they have opposite spins to cancel their electromagnetic repulsion. Well, we're going to have 2 electrons in this bond, but for the other 2, we've got to put them someplace else. We can't put them in the same space. They won't fit. They want to fly apart. So for that, then, what we're going to do is have 2 p orbitals. There's a p orbital here on the carbon and a p orbital here on this oxygen, okay, that are unhybridized. And they're going to reach out and form a pi bond. So both parts of this p orbital are going to join up. A pi bond has 2 parts, or what appears to be 2 parts. It's all one bond, okay, but it looks like it has 2 parts. There's the first part, and there's the second part where they go out and touch each other like that. So these 2 together make up a 1 pi bond. We could call this pi y, I guess. Okay? Does that make sense? Now, then our lone pairs over here, those are in our single balloon shapes over here. Those are hybridized orbitals. And I've got one here and one sort of behind it here. All right? And these 2 single bonds, those are sigma bonds. All single bonds are sigma bonds. And so they're going to be one in front and one in behind too. Okay? Where hydrogen's sitting out here, and those are the sigma bonds. Okay? But the shape of the double bond is just this part right here. Got that? And we did that with balloons. Remember the balloons we did? And that's what we're trying to show, is that this part right here, all of this going around the top and the bottom, all together, top and bottom together, make up just 1 pi bond. So a double bond has a sigma bond and a 2-part pi bond. Got that?
And a triple bond is a sigma and 2 pi bonds?
A triple bond is 1 sigma and 2 of these pi bonds. Okay?
You had them overlapping, right?
Well, you have one kind of above and below, and then one coming out in front and one behind.
Side, right?
Mm-hmm.